In this video, we're going to talk about linear functions. Before we talk about linear functions, let's talk about some key words that the IB will be using. And those key words are the difference between sketch and draw. Let's look at the definitions the IB provides us. Sketching, represent by means of a diagram or graph labeled as appropriate. The sketch should give a general idea of the required shape or relationship and should include relevant features. Let's compare that to the definition for draw. Represent by means of a labeled, accurate diagram or graph using pencil. A ruler straight edge should be used for straight lines. Diagrams should be drawn to scale. Graphs should have the points correctly plotted, if appropriate, and joined in a straight line or smooth curve. So the main difference between these two are that a sketch is a rough draft, so a drawing is more precise than a sketch would be. And those are keywords that the IB will be using throughout this unit, so I thought I'd introduce it now. Another thing that the IB likes to introduce is what they call the modeling cycle. Now, this modeling cycle we're going to be seeing also when we are doing our IAs. However, what we're going to be doing throughout this course is we're going to be given a real-life problem. Our objective is going to be to develop a model. Now, when we say develop a model, we mean a function. So we're going to come up with a function that talks about the real-life problem. What we're going to do is we're going to test the model. So we're going to try to plug in some numbers and see how realistic it is. If it is realistic, then perfect, we can use this model. If it's not realistic, then we're back to square one and we create a new model. So this is kind of the process that's going to be happening throughout this unit as we're given some real life problems. We need to think critically about what type of function best represents each type of problem. Now let's get started with our linear functions. The first thing I want to do is a little reminder as to how do we write a straight line. So in order to write a straight line, there are three notations that the IB is going to be using. The first one is the gradient intercept form. Now the gradient intercept form is the one that we're most used to, which is the form y is equal to mx plus c, where we have m is our slope or gradient depending on how you write it, and c is our y-intercept. The next form is point gradient form. Now point gradient form is given as y minus y1 is equal to mx minus x1. And this x1 and y1 represents any point on our graph. So any coordinate is represented by this point x1, y1, while the m is still our slope or gradient, same as our first form. And the second form is the general form, which is in the form ax plus by plus d is equal to 0. Now in this form, a, b, and d don't represent anything on our graph. Next up, let's remind ourselves about the slope or about the gradient. When we have a gradient like the first one we see here, which is increasing, this means that we have a positive slope. The next one is a negative slope. The horizontal line means that we have a 0 slope. All horizontal lines have the equation y is equal to a number. So this is going to be very important for us to remember as we find the equation of lines. And the vertical line actually is not even a function itself. Remember, this vertical line does not pass the vertical line test, so it has an undefined slope. And the equation of this is x is equal to a certain number. And this is going to be the equation of this relation, this vertical line. Let's practice finding the equation of a line. So if we're given a graph as such, how would we find the equation of the line? Well, we can use any of the format. I like to choose the gradient intercept form, remembering that our c is our y-intercept. In this case, our y-intercept is the value of 3. And then for our slope, well, we can use the slope formula, which is given to us in the formula booklet, that states that our slope is y2 minus y1 divided by x2 minus x1. This is given to you in the formula booklet. And in order to find this, you can find any two coordinates on your graph. So if I use the first coordinate, which is 0, 3, and I can use this coordinate here, which is 5, 1, and I can have 1 minus 3 divided by 5 minus 0. And I'm going to get that the slope here is negative 2 over 5. Negative, does that make sense? Well, yes, because my function is decreasing here, right? Another way that you can see the slope is your typical rise over run. So what's happening here, if you go from point A to point B, you're rising in negative 2, so you're going down 2, and you're going towards the positive direction, 5. So this slope does make sense. So putting everything together, the equation would be y is equal to negative 2 divided by 5x plus 3. Next reminder for today, parallel and perpendicular lines. So if you have two lines that are parallel, this means that they're going to have the same slope, the same gradient. If you have perpendicular lines, well, that means that you're going to have the slopes being negative reciprocal of each other. So if this first slope is m, the second slope is going to be 1 over m and negative. So this is how you're going to go between perpendicular lines. Their slopes are negative reciprocal. Let's try some examples together. Example 1. Let me zoom into example 1. Write the equation A, this equation in general form. General form, we remember ax plus by plus d is equal to 0. The key to general form is that it has to be equal to 0. So what I'm going to be doing is I'm going to be sending everything to one side, making it equal to 0. And then a, b, and d, most of the times in the IB exam, will say that a, b, and d need to be integers, element of the integers. So we're going to make sure that a, b, and d are integers. In order to send everything to one side, I subtract both sides by y, and I get 0 is equal to negative 2 over 3x plus 2 minus y. So in order to have integer values here, what we're going to need to do is we're going to need to multiply the entire equation by 3, which is the denominator that the x variable has. When we do that, 0 times 3 is still 0. We're going to have negative 2x plus 6 minus 3y. And this is going to be our equation in general form. Next, write down this equation in gradient intercept form. Gradient intercept form is going to be this form here. So what we need to do is we need to isolate so that y is all alone on one side. So what I'm going to start by doing is I'm going to start by subtracting 3x on both sides. I'm going to get negative 4y is equal to negative 3x minus 2. And then I'm going to divide by negative 4 on both sides. And I'm going to be left with y is equal to negative 3 divided by negative 4. The two negatives cancel out. I'm left with 3 over 4x. Negative 2 over negative 4. The negatives cancel out. And I'm left with 2 divided by 4, which is 1/2. And this is your gradient intercept form. Example 2. Find in gradient intercept form, so y is equal to mx plus c, the equation of the line with a gradient of 3 that passes through this point. Okay, if the gradient is 3, then we know that the equation will be y is equal to negative 3x plus c. if we know a point on the graph, I can replace this as x and y in order to find my y-intercept. So I'm going to have -5 is equal to -3 times x, which is 4, plus c. So at this point, what you could do is you could put this into your calculator as nsolve. So we can go math, numeric solve. First part is -5, and then we have -3 times 4 plus what we're looking for, which is x, and we click on solve, and we get that the value of c is 7. So if we write down the equation in point gradient form, we get y is equal to -3x plus 7. Let's continue with our next example. As punishment for misbehaving, Jack must pick up litter at lunchtime. This table shows how many pieces of litter he has picked up after t minutes. The graph alongside shows these data points as well as the linear function n is equal to 8t plus 0.2. Is the linear model exact or appropriate, and explain your answer. Exact or appropriate refers to, are every single point on this line, or are we doing what's called a regression and finding the best fit model? If we look at these points here, we notice that not all the points are exactly on the line. However, it seems to be a very appropriate model because the straight line does follow the points very well. So our answer to part A would be approximate, because the points are not exactly on the line. B. Use the model to predict how many pieces of litter Jack will pick up in 20 minutes and discuss the accuracy of your prediction. Okay, so using this model means we're going to be using the function. 20 minutes, this represents our t value. So we're going to have n is equal to 8 times 20 plus 0.2. So we're going to have 8 times 20 plus 0.2. And we're going to get 160.2 pieces of litter. Now the next part of the question is to discuss the accuracy of our prediction. Now this should be familiar to us because we did this with our statistics unit when we were doing Pearson or Spearman regression. If we think about the t value that we put in, 20 minutes, and we look at the data that we have, the data we recorded, we only recorded for up to 5 minutes. 20 minutes is outside of the range of our data. So since 20 minutes is outside the range of our data, we say that this would be an extrapolation. So even though the straight line is a good fit for our points, it represents an extrapolation which is not accurate. Our next example. A water tank drains at a constant rate. It contains 930 liters of water 3.5 minutes after it started to drain. It takes 50 minutes for the tank to empty. Let W be the amount of water in liters in the tank, T be the minutes after it started to drain. Find a model for W of T, the amount of water in the tank at any time after it started to drain. Write down the rate at which the water tank is emptying. Okay, so for this question, since we're talking about emptying at a constant rate, that means that we're going to have a constant decrease, a straight line decreasing. So we're going to be using a linear model in order to model this situation. So I'm going to go ahead and use the gradient intercept form to talk about this. We have a first piece of information that says that after 3.5 minutes, we have 930 liters of water. So this is a key point that we have. After 3.5 minutes, which represents the T, we have 930 liters. Then we have another key point, which says that after 50 minutes, the tank is empty. So 50 minutes, our volume of water is 0. Using these 2 points, I'm now going to find the equation that best fits this. First, I can find what the slope is by using the slope-intercept form. So the slope is y2 minus y1 divided by x2 minus x1. So doing this onto your calculator, we get that our slope is negative 20. And then our next step is to find out what the y-intercept is, the value of c. So now I know the slope, and I can use any of my 2 points in order to find what the value of c is. So I could use, for example, the point 0, 50, 0. And in order to do this, I can use the numeric solve, clicking on solve, and I get that the c value is 999.999, so I'm rounding this to 1000. So the model that we have is negative 20x plus 1000. In part A, they're asking us, write down the rate at which the water tank is emptying. The rate at which the water tank is emptying is our slope, decreasing, so I can say the rate is decreasing because it's negative at 20 liters per minute, because those are the units for our liters, so for the water volume and for our time. Part B, write down the amount of water in the tank when it starts to drain. When it starts to drain, that means that we have our time is equal to 0. So we're looking for the y-intercept here, and that would be 1,000 liters. So our y-intercept is 1,000 liters. We're starting with 1,000 liters in our tank. And C, using your model to find the amount of water in the tank after 30 minutes. After 30 minutes, then we have our t value is equal to 30. So we're going to have y is equal to negative 20 times 30 plus 1,000. So negative 20 times 30 plus 1,000. We're going to have 400 liters left in the tank after 30 minutes. And our very last question for today. In a chemistry experiment, a liquid is heated and the temperature is recorded at a different time. Some results are shown in the table below. Plot the graph of this data on your GDC. Anytime you have data, let's put that into our list. So we're going to go and edit our list. In list 1, I want to see the time. And in list 2, I want to see the temperature. In order to see the data points, we need to go second, stats plot. We have to turn our stats plot on. So we're going to turn it on. Scatter plot is what we want. List 1 and list 2, that's correct. So when we go back onto our graph, I can remove the graph that I have here, and I should see my data points. Choose an appropriate model to justify your decision. Okay, let's zoom into the points to see what is the best model that we're thinking for these points. These points seem to follow a linear function, so it seems to be linear. Now, how do we justify our choice? In order to justify our choice, we're going to need to use either the R value for linear function, right? So this, remembering, is Pearson regression. And then in our next functions, we're also going to be using what's called the R squared value. And this is going to be for nonlinear functions. So I'm going to be coming back to this point of the r squared value. But since we think that our appropriate model is linear, I'm going to go ahead and run a linear regression, which should be familiar to us because we did that in our statistics and probability unit. Linear regression, list 1, list 2. We don't have a frequency. If you would like to store the linear regression, then what you could choose is a y1 or y2. So what you do is you go alpha, trace, and you see all the options are here. I'm going to choose y1, and I'm going to go ahead and calculate. And I calculate, if I don't have an r value, then you know that's because your mode is on stats diagnostic off. So I'm going to go ahead and change my mode and repeat my steps. And calculate. And now I have an r value. So I'm ready to answer part B. I'm said I think it's linear, and is it a justifiable answer? Yes, because my r value is 0.999, and even if I would round it, my r value would be approximately 1. So this is a very good decision to use a linear function. Part C. Determine a reasonable domain and range for your model. Domain and range. Domain refers to the x, range refers to the y. So domain refers to the time. So my domain for the time goes from 4 all the way to 10. So my domain is from 4 all the way to 10. While my range, it goes from 100, so we have 130 to 369.2. Part D. Find an equation for this model and plot it on your graph. Find an equation for the model. Our GDC, we see that the equation should be 39.9x minus 29.5. You can see this on your graph because we stored the regression equation as y1. So on the graph, we see this equation. C, comment on your model. So for part E, commenting on the model means how reliable it is. So since we have an R value that's almost equal to 1, this is a very good model. For part F, use your model to estimate, for part I, what is the temperature of the water tank when we have 4.5 minutes. So in order to do that, we use our equation and we replaced our time, our x, by 4.5. So what we could do is we could do trace, and we get that our model gives us that y should be equal to 150.1. For double I, now we have time is equal to 20 minutes. So we have 39.9 times 20 minus 25. So you could do trace, or you could do 39.9 times 20 minus 29.5. And we get that we should have 768.5. And the last part of this question is to comment on the predictions of part F. In order to comment on the predictions, we need to think about, is this an interpolation versus an extrapolation? So you're used to this by now because this is basically what you were doing with Spearman. So if we think about this question, part I, 4.5 minutes, this would be an interpolation. So this would be a reliable estimate. For time of 20, this would be an extrapolation, right? Because it's way bigger than our domain, which stops at 10. So this would not be a good estimate.